Hi friends, I'm Harpreet Singh Walia, having 20 plus years of experience in information technology. I'm SnowPro Core certified, and today I'll take you through the demo of the unmanaged Iceberg table. This is second part of my previous video of the Snowflake Iceberg managed Iceberg table demo. If you have not watched that, I would strongly recommend you to watch that, as it has covered problem statements, Iceberg concepts, and demo. In this tutorial I'll provide you use case, brief introduction on Athena and Glue, followed by demo on Snowflake unmanaged Iceberg tables. Unmanaged tables. Storage management in data lakes. Unmanaged tables in the context of data lakes usually refer to tables where the data is stored externally, and the table metadata is managed by a system like Apache Hive, AWS Glue, or a similar data catalog. The data can be in various formats, and the table schema is defined separately from the data storage. Unmanaged Iceberg tables are read-only and performance is very good. Performance to some extent depends on how Parquet is written. Different systems write it differently, but Snowflake will provide the best possible performance. Use case for using unmanaged tables is when the data needs to remain in external storage only, such as AWS S3 bucket, and the same needs read-only access from Snowflake. Following is needed for the unmanaged Iceberg tables. 1. S3 for storage of data. 2. Athena for SQL DML operations over data. 3. AWS Glue for metadata catalog. A typical workflow with Athena involves defining tables for your data using the AWS Glue data catalog and then running SQL queries using the Athena console, API, or other supported tools. AWS Glue provides a centralized metadata repository called the Glue data catalog. This catalog stores metadata information about your data, such as table definitions, schema information, and partitioning. It helps in discovering and managing metadata across different data sources. AWS Glue is integrated with Snowflake, and Snowflake will be able to query data directly. Snowflake will not store any data, data will remain in S3. Amazon Athena is a powerful tool for ad hoc analysis and querying of data stored in Amazon S3 without the need for traditional databases or data warehouses. It's important to note that the specific use case would depend on your organization's requirements, data processing patterns, and the nature of the data you are dealing with. The combination of unmanaged tables in Snowflake and Iceberg tables, or a similar concept, could provide a flexible and efficient solution for managing and analyzing large volumes of data. Key features of AWS Athena include serverless architecture. Athena is a serverless service, meaning there's no need to set up or manage any infrastructure. You don't have to worry about scaling, patching, or maintenance. SQL queries. Athena uses standard SQL for querying data stored in Amazon S3. This makes it accessible to users who are familiar with SQL, allowing them to run ad hoc queries and analyze data easily. Data formats. Athena supports various data formats, including CSV, JSON, Parquet, Avro, and more. This flexibility allows you to work with different types of data. Integration with AWS Glue. You can use AWS Glue to catalog your data stored in Amazon S3, making it easier to discover and query. Athena can also work with tables defined in the AWS Glue data catalog. Security. Athena integrates with AWS Identity and Access Management, IAM, allowing you to control access to your data and queries using IAM roles and policies. Pay-per-query pricing. With Athena, you pay only for the queries you run. There are no upfront costs or ongoing commitments. A typical workflow with Athena involves defining tables for your data using the AWS Glue data catalog or by directly querying your data in S3, and then running SQL queries using the Athena console, API, or other supported tools. Overall, Amazon Athena is a powerful tool for ad hoc analysis and querying of data stored in Amazon S3 without the need for traditional databases or data warehouses. Key features of AWS Glue include data catalog. AWS Glue provides a centralized metadata repository called the Glue data catalog. This catalog stores metadata information about your data, such as table definitions, schema information, and partitioning. It helps in discovering and managing metadata across different data sources. ETL jobs. Glue allows you to define and run ETL jobs to transform and prepare your data for analysis. ETL jobs can be created using a visual interface or by writing Python or Scala code. Glue takes care of the underlying infrastructure and scaling, making it a serverless ETL solution. Data crawlers. Crawlers in AWS Glue automatically discover and catalog metadata from various data sources, including Amazon S3, relational databases, and data warehouses. This makes it easy to understand the structure and format of your data without manual intervention. Serverless execution. Glue is a serverless service, meaning you don't need to provision or manage any infrastructure. AWS takes care of the infrastructure, and you only pay for the resources used during the execution of ETL jobs. Integration with other AWS services. AWS Glue integrates with other AWS services such as Amazon S3, Amazon Redshift, Amazon RDS, Amazon Aurora, and more. This enables seamless data movement and integration across the AWS ecosystem. Data transformation. Glue supports data transformation tasks, allowing you to clean, enrich, and transform your data as part of the ETL process. You can use pre-built transforms or create custom transformations using Spark ETL code. Overall, AWS Glue simplifies the process of preparing and loading data for analytics by automating many of the steps involved in ETL. It is suitable for a wide range of use cases, from data warehousing to data lake analytics. Let's start with creating storage. We will create two storage, one for the table called Product List 2023 and the other called Query Output 2023 for query, which will be used internally by Athena. Create a bucket. Give it a name Product List 2023. For this demo, we will allow public access to keeping it very simple. Click Create Bucket. You can see the bucket created. Now create a second bucket by the name Query Output 2023. You can keep all settings as it is. Click Create Bucket. Now both are created. Now create Glue Catalog and Athena. First, we will create a workgroup product WG, then a database by the name product DB, followed by a table with the name product having two columns ID and name. Click Athena. Go to Workbooks and click Create Workbook. Give it a name product WG. Expand Query Result Configuration and select S3 Query Output 2023. Click Create Workgroup. Now Workgroup is created. Now go to S3 to check data in both buckets. You can see there is no data as of now. Now let's come back to Athena. Select Workgroup Product WG. Create Table Product. Select the new database and give it a name Product DB. Select Bucket Product List 2023. Select Table Type as Apache Iceberg. And select File Format as Apache Parquet. Create two columns with the name ID and name. Click Create Table. The table is created now. Let's check S3 buckets. You can see metadata folder has been created. And Query Output also has some files. Now insert some records. Let's check S3. You can see a data folder created and it has a Parquet file. Let's insert another record. Let's select this table. It is now showing 2 records. Let's insert another record and check the bucket again. You can see now more Parquet files are being created. Let's browse all folders. Now let's see the data catalog. You can see the database and tables created in the catalog. Now we will create roles and policies so that we can access the catalog and data from Snowflake. We will create 2 roles and 2 policies, one for S3 and the other for the Glue catalog. Let's create the first role for S3. Select Service S3 and add permissions. Give it a name S3 Read Only and click Create Role. Let's create a second role, select Service Glue, and add permissions. Give it a name Glue Role. Next, create a policy. Select Service S3. Resources select all. We are just keeping things straight and simple for the demo. Click Next. Give policy name S3 Policy. And click Create Policy. Create a second policy. Select Service Glue. Check all Glue actions from Actions Allowed. From Resources, click All Radio button. Create Policy. Select Customer Manage Type and you can see now 2 policies created. Now go to Roles and attach a policy to its respective roles. Do the same for the second role. Now we can create integration. First, we will create external volume and then integrate the catalog. Let's create an external volume with the name prod volume. Run the command. It's created successfully. Now create catalog integration with the name glue catalog int. It's created successfully. Now describe the external volume and get the strings that we will need for the configuration on AWS. Now go to AWS. Go to role S3 roller readonly and click Trust Relationship. Click Edit Trust Policy. Add these configurations and click Update Policy. Do the same for the catalog. Describe the catalog and get the strings that we will need for the configuration on AWS. Now go to AWS, go to Role Glue Role, and click Trust Relationship. Click Edit Trust Policy. Add these configurations. Now integration is complete, we can create a table now. We will create a table product and query the same. Run the create table command, provide external volume and catalog. The table is now created successfully. Now do select. We can see the same records that we saw in Athena. Now let's insert one more record from Athena. Do select. We can see 4 records. Let's check the same in Snowflake. We will select and then do the row count. We can see that this is not synced yet. For this, we will have to refresh the table using the alter table command. It's successful. Now let's check the records again. Now we can see up-to-date records. Now we will delete 2 records from Athena. Let's check the same in Snowflake. Let's check. No change yet. Let's refresh the table. This refresh is manual now, maybe in future releases it will be automatic. After refresh records are updated, we can see 2 records deleted. Now let's try to do a DML operation from Snowflake. You can see this operation failed. The snowflakes have read-only access on the unmanaged Iceberg table. So this is what is expected as a result. This completes our demo. Thanks for watching. Please subscribe if you like my work and I'll keep getting more informative tutorials like this. See you in the next tutorials.